Hello, this is Carlos Martinez, student at California Intercontinental University. This course, Business Research and Quantitative Statistics, is the reason for this presentation. This presentation is entitled Visualizing Hypothesis Testing. Our agenda for the presentation is as follows. We will review by example concepts of hypothesis testing using 4 examples. We'll state and justify the null hypothesis and alternative hypothesis, if applicable, for each of the 4 examples. We'll state the main takeaways and ask for questions at the end of the presentation. There are 2 basic types of hypothesis testing: testing for research and statistical testing. This presentation will involve a basic framework of statistical testing, but for research. In our presentation, we will examine the following 4 hypothesis visualizations. Number 1, we'll test for a single simple mean. 2, comparing 2 groups, which means 2 means. Efficiency comparison and a correlation test. I have included in this presentation a set of definitions, very basic and very brief, from the text as well as from the Minitab blog for your review. I won't take the time to review each one of these, but back to them as we evaluate our testing. The first test is a test for a mean. My null hypothesis is that all of the widgets on average from Acme Widget Company have no defects. My alternative hypothesis is on average the widgets from Acme Widget Company are not defect free. The research question, on average, are the widgets from Acme Widget Company defect free? As I look at the visualization, I see an area in the bell of 95% where that could be defect free. However, I have a 5% confidence factor. So I have plus or minus 0.025 in each of the tree, minus on the left side and positive on the right side. My alpha 0.4 or 4.56, I rounded off to 5. According to the visualization, I have a 40% probability of having 0 defects, but not at 100%. So I'm going to go with the alternative hypothesis that on average the widgets from Acme Widget Company are not defect free. Visualization 2 is comparing 2 means or 2 groups. The research question, does the average major league team have more home run hitters than its corresponding minor league team? The major league team is represented by the curved blue. The minor league team is represented in red. I've got 2 variables. They appear to be independent variables or independent of each other. The null hypothesis can be written as one being equal to the other. The average major league team has more home run hitters than its corresponding minor league team can be written as an equal, so I have that null hypothesis as one bell curve equaling the other. The alternative is the opposite. The average major league team does have more home run hitters than its corresponding minor league team. So as I evaluate this, I really need more information. I need to know the frequency of the teams, how often, how long they play, how many home runs they hit in order to make a comparison between the 2. So I would normally say fail to reject the null. However, just based on the information that I have in front of me, I'm going to go with the hypothesis that the average major league alternative hypothesis and reject the null. Visualization. Number three, efficiency comparison. We're comparing two scales of efficiency. The null, well, the research question is the efficiency curves of the red and blue teams were recorded. Do the teams have equal mean efficiencies? So the null hypothesis can be written as one equaling the other. The blue team is equal to the efficiency of the red team. The alternative is that the blue team is not equal to the efficiency of the red team. So in my visualization analysis here, it seems as though the red team has 30 serve in 10 hours. The blue team 50 serve in 4 hours. So the mean of the 30 for the red team and the mean of the 50 for the blue team is not equal. I would reject the null hypothesis. Visualization number four, correlation test. A German study tested how larger industrial use fans utilize gasoline, and one of their analysis plotted miles per gallon versus the weight of the various fans in the study. After plotting the data on a scatter plot, which is the scale I have in front of me here, the researchers performed a correlation test and found a significant correlation. However, they forgot to state their hypothesis test in the published paper. So the question is, what were the study's null and alternatives? The null can be written as the van weight does not equal to the amount of fuel used with the two. The alternative is the van weight has a correlation between the amount of fuel used. As I look at the visualization, it appears that there's no relationship between the weight and the usage, whereas on the alternative, the correlation between the weight and the usage is different. I calculate a significant value of at least 0.01, and I reject the null hypothesis here. There is a correlation between the weight of the vans and the miles per gallon that they get. The heavier the van, the least miles per gallon. So my p-value is 0.0001, and being 0.0001, I reject the null hypothesis. Okay, my takeaways. First, we begin with clear definitions, valid assumptions, and establish a framework that is sufficient for both data and for visual analysis. Two, a hypothesis test examines two opposing hypotheses, the null and the alternative, and both must be testable in order to find credible findings. So the third hypothesis test takeaway. Based on the sample data, the test results determine whether to fail to accept the null or to reject the null hypothesis. Using visualizations, visualizations provide a very interesting, a clear analysis, because using the visualizations, I'm asking more questions than I probably would ask just based on the data alone. And then when I narrate that, I can point out particular things for the viewer to look at in terms of using visualization. Thank you for watching. If there are any questions, and here are my references.